In this video, we're going to look at finding the volume of a solid of revolution. So we've got the function y equals root 25 minus x squared. The region that we're interested in is going between that function and the x-axis, and then in between the lines x equal to 2 and x equal to 4, and we're going to rotate about the x-axis. So first off, this picture on the left-hand side is just a drawing, a graph of the region that we're interested in. After we revolve this around the x-axis, so this black piece here is just that same region, and we're revolving it around the x-axis, so the red line here is referring to the x-axis, so this piece right here would be the outer surface of the solid that we're interested in. So there would be a face here that would be closed off, a face here that would be closed off, and we would be interested in finding that volume. All right, so when we find the volume of this, we're going around the x-axis here, and since we have this function given to us in terms of x, it would be nice to be able to integrate with respect to x. Since we have a function of x, it's easier to integrate with respect to x. All right, so if we have a function of x, then we notice that our slices here, we're going to slice up the x-axis. That'll be perpendicular to the x-axis. When we get things that are perpendicular to the x-axis and we rotate them, we get, this is a back view of this, we get this disk. So notice here would be our perpendicular slice to the x-axis. We would take that slice, rotate it around the x-axis, we get a circular disk. So when we want to find the volume of that particular disk, we would need to find the area of the face and then times the dx, or the delta x, its thickness. So what would be the area of this face? Well, we need to know what the radius is and do pi r squared because it's a circular disk. All right, so here is the radius. It's the length of that slice. Well, where is that radius coming from? It's the height of the function. So our radius would be root 25 minus x squared. We'll do pi times the radius squared, and we'll integrate that from 2 to 4 for our bounds for our x. Well, the squaring and the square root cancel each other out, so we're just going to integrate 25 minus x squared from 2 to 4. Notice we took the constant pi, plopped that out in front. Find an antiderivative, we get 25x minus 1/3 x cubed. Use our fundamental theorem of calculus to evaluate, and we should get 94 pi over 3.